But it was Tesla who discovered that you could actually generate this kind of energy from equipment, well, he was an electrical engineer. All the previous people were studying the subtle energy as it came out of the body, like energy from healers and the like. But Tesla was really the first person in modern science who said, well, I want to be able to generate this kind of stuff in the lab, and I want to experiment with it. Now, you have to realize that Tesla was the first person to really talk about alternating current, because at the time, the dogma with Edison was all about DC current. And this was like in the turn of the 1900s, when electricity, hit the road, and all of a sudden we discovered it and we realized that we could light up our homes and all that stuff. But Edison was all about DC. Tesla was all about AC, alternating current. And that's what Tesla's famous for. But what he's really famous for is having discovered what he called longitudinal waves. And the technical term now is longitudinal scalar waves, because they're not, the conventional electromagnetic field is called the transverse electromagnetic field. Here we go technical on you. And these kind of scalar waves are longitudinal, and the difference is the direction of propagation of the vector component of the field. So the electromagnetic field has an electric component and a magnetic component, and they are 90 degrees apart. Okay, so when the wave propagates, these electric and magnetic vectors move like this as the thing goes forward. But that's a transverse wave. But in a scalar wave, they're kind of like this, and they move this way as the wave goes forward. Sorry, I should have a diagram for that. Excuse my fingers. But Tesla was the one who first discovered that these longitudinal scalar waves exist. He figured out how to generate them, as is shown in the slide. This is what's called a flat Tesla coil. And it's kind of brilliant because it's sort of visible, but not really. You've got two wires coming in. I don't know how to put oh, here, can you see this little arrow on my screen? Hopefully you can. And this arrow on my screen is showing where the two current flows come in to the coil. One goes this way. Whoops, sorry. One goes this way, and then it goes around the outside. And then when no, I'm sorry, it comes in, it's actually this one here, comes in, and it goes from the outside in. It follows in a spiral into the center. Then when it gets to the center, it goes through the center to the other side, and then spirals out the other side in the opposite direction. So you have what's called counter-rotating coil, which means that the electricity is going in the opposite direction, and it cancels itself out. And so this is called the self-canceling coil. And when you do that, you cancel the electricity, you cancel the electric field and the magnetic field generated from the moving electrons, and you cancel the whole classical electromagnetic field, because they basically oppose each other 180 degrees, and they cancel. And Tesla discovered that there's another kind of energy underneath the classical, gross, dense force fields, which is a subtle energy, and he called that scalar energy. Not only did he discover that and a way to generate it, but he did these amazing experiments, like bounce this kind of energy off the ionosphere and then off the surface of the Earth. So this kind of energy was bouncing up and down over the planet, and he could actually send this energy globally across the planet. And he could this energy, the most amazing thing that he did was hold a light bulb in his hand in the desert, and he could light the light bulb with this scalar energy as it bounced off the ionosphere. I guess it would hit his body, which acted as an antenna, and that would light the light bulb in his hand. So, I mean, Tesla was absolutely brilliant, and he's really the father of subtle energy, in my humble opinion. Okay, so there's Tesla. There's a little bit of history. Since then, scientists have decided that they want to give this energy. I'm sorry. They want to give this energy all kinds of different names. So they don't know what to call it because it doesn't obey the laws of Maxwell and Hertz. So they called it non-Hertzian and non-Maxwellian and non-dispersive and non-Abelian. That's because they don't know what to call it. So they call it what it's not. They say what it's not. But what it is a potential field, as I said in the introduction, not a force field. It's a longitudinal scalar wave. And there are many different kinds of non-classical electromagnetic fields. This is just a few names of some of them. Now this one here is interesting. So this means E parallel B. This is in the physics literature, where the E field and the B electric and magnetic fields, remember I said before, they were perpendicular. That's in a normal classical electromagnetic field, they're like this. But there are kinds where the E and the B field are parallel, which is kind of hard to even visualize. But they've got lots of different names. Okay, so there's a bunch of names. Here's some more names. I love this one, the null field, because it's because the two classical electromagnetic fields cancel that we just described, that Tesla discovered. So they call them null fields. They call them self-dual fields. There was a guy called Beltrami who discovered this, what he called a helicoid field. And the shape of what's unusual about these kind of fields is the shape of the field. And the shape is depicted on the diagram on the right, which is a rather unusual field. It's more like a spin field. Instead of things moving, this way, they move in a spiral. So then we have vortex fields that Konstantin Meil has talked about, and all these other kind of fields that you can read for yourself that I don't have time to discuss. Konstantin Meil is a German scientist who's been doing some contemporary research with scalar energy. And because Tesla died, and then after that, there was Tom Bearden. That's where we're talking about the history again, right? Okay, I'm jumping all over the place. So Tom Bearden was one of the first real scientists after Tesla to take up the bandwagon of the scalar energy story. And he gave a lot of lectures, and he tried to simplify it, but it gets pretty technical pretty fast, as I said. And then after Bearden was Meil, and then right around the same time, Konstantin Meil and myself were doing all kinds of research with scalar energies. There was Eldon Bird, who had done some work with scalar energy. Not a lot of people, I got to say. But nowadays, this sort of this research on scalar energy, we went through this. I guess, am I going the wrong direction? Oh, okay. Has reached the scientific literature. But before we get to the contemporary scientific literature, let's look at some of the different properties of a classical electromagnetic field or a transverse field, as